So that's all about PYQ. So thing
Okay.
is, what I am going to do in today's session. So I will basically start with quick revisions of week concepts of week 9 and week 10. Okay, we will not go into too much depth because already we have done all the derivations and all in our open session. So what we will do today, we will quickly revise the content, and then I have collected some questions from week 9 and week 10, which have been already asked in previous quizzes. Okay, which is basically you can say it's previous year questions itself only. Okay, so we will discuss and we will try to solve those questions. I hope this is fine to all of you.
Okay, okay, sir. No
Okay.
problem. Hmm.
Okay, so we'll quickly cover the content. So as if you need any derivation and all those kind of thing, I think you can refer the open session. But today is all about
We have already attended open session. No?
correct, correct.
Yes.
Yeah, yeah.
We
Yes,
just
yes,
need the approach of question solving now.
yes, Priyansi.
Okay.
Sir, I am finding the difficulty in solving week 11 questions. I have done all the in the activity questions. I didn't find any
Today's
difficulty,
okay, so
but
we can discuss at the end of the session because today's session is about week 9 and week 10 revision session. Okay, so
okay, sir.
let's yeah, yeah. Did you attended yesterday's session or not?
Yes, sir, attended it.
Okay, so try to apply those concepts and all. Okay, because uh, anyway
Okay.
that will help you. But if at any point if you have if you have any difficulty in any of the question, you can basically type to us on Discord. So and you can share your approach also, right? Like this is this was your approach where you are finding difficulty and all. Okay, that's the better
Okay.
thing rather than asking the solution directly. Yes, Abhishek, do you have any query?
Yes, sir. Good evening, sir.
Good evening.
So actually, I have problem in week 9 practice assignment questions. So I request you please take few questions from those assignments also.
Okay, we'll take. So first, quickly, I will cover the content of week 9 and week 10. Okay, so we'll go as per the agenda of the today's session. Okay, I will quickly revise the concepts of week 9 and 10. Also, I'm going to discuss the questions which we have asked in previous year questions from previous year terms in from the week 9 and week 10 concepts. Okay,
So
so
what
that's
I
our agenda. Let's try to finish that, and after that, if you have any doubt, we will try to cover. Okay.
actually what I'm saying, please take few questions from practice assignments of week
We'll
9.
take that I've said. So what I'm saying, see, most of the time you people are asking to solve some questions we have already asked in previous year term, right? So
Okay.
that's what we have collected the questions from there. We'll try to solve those questions. After that, we will discuss the questions. That's not a problem. Okay?
Okay, sir. Thank you very
Sounds
much.
good? Yeah. Yes, Janvi, do you have any question?
Sir, will the interim be for 40 months or 50 months?
Anyway, at the end, it will be converted to out of 100. Okay?
Okay, sir.
Yeah. Okay, all right then. Good evening to all of you. Let me share my screen and we will quickly go through the content of week 9 and week 10. Okay, so can you see the screen, white PDF?
I will like
Yes.
Yes,
yeah,
sir.
I can
Oh,
see.
okay, great. So very first thing in week 9, okay, so that's called estimator. Okay, that is something we have discussed already, but I will cover all the concepts. So what is the estimator we have seen? Okay, before this, let me start something like this. Suppose we have x1, x2 till so on xn. This is IID samples. Let's say from normal mu comma sigma square, for example. Okay, so you can see this mu, this sigma square, these are all are the constants, right? Because these are the fixed values, correct? And this is what, this is your IID sample, correct? So what is the estimator? First of all, if I would like to write the um, definition of estimator, so estimator is nothing but it is the function of the samples. Okay, so what is the function of sample? Suppose let's say function can be anything. So if this x1, x2, xn, these are the your IID samples from normal. So this is one particular distribution. It can be anything. That's this is not something it should be always normal. So function of sample means, let's say I'm saying x bar. So x bar is what? 1 upon n summation of xi. So what is this? This is function of samples or not? Okay, you can define anything, let's say something x1 plus 2x2 divided by 3, something like that. This is also function of estimator, sorry, function of the samples. Okay,
Yes, sir. Yes.
so based on okay, also these all values can change, yes or no? So based on this, based on different sampling instances, you will get different values of for this function, different values for this function, yes or no?
Yes, sir.
Yes,
Correct.
sir.
So this means estimator is what? This is not a constant, this is a random variable. Okay, so generally notation is we are writing just a theta hat is estimator, and in bracket we are writing something like this: x1, x2, xn. So what is this estimator? This is the nothing but function of the samples. Okay, it can be sample mean, it can be x1 plus 2x2 divided by 3, it can be x1 only because it can be 2x2 divided by no 3, something like that, any function of your samples. Okay, so estimator is random variable, and these parameters, these are called the distribution constant. Okay, parameters of the population, these are the constants. These are not random variable because this is something fixed value. Now something occurs that is called estimation error. Okay, so what is the estimation error? Estimation error is nothing but we can define error as a error is defined as theta hat minus theta. Okay, so what is this theta hat? This is the estimated value, this is the original value. What, tell me, this theta hat is what? This is random variable, and
Yes.
theta is the, I'm talking about, let's say here we say it's a mu comma sigma square, so it can be theta. I mean generally we are taking as a theta, so this theta is a constant, right?
Yes,
Now
sir.
tell me whether these quantity theta hat minus theta will be random variable or constant.
Random.
It's a random variable, right? Okay, great. So this is the error defined like this. So always tell me, you should okay, suppose I'm writing something like this: probability that no absolute value of the error is greater than some quantity delta. Okay, this is a small quantity. Tell me whether you would like to should be, what should be this whole quantity? You are saying the absolute difference. See, when you will say your estimator is good, means it is very close to the original value, right? Difference is very close,
Yes, sir.
right? So if I'm saying probability that absolute value of error is greater than delta, what is this? This would be what? This would be small, right?
Small.
This
Yes, sir.
probability should be small. Okay. If I will write in reverse order, let's say I'm writing probability that absolute value of error, this is less than some quantity. So this whole quantity should be
Last.
large. Okay. So just think a bit about this. I think we have discussed in open session also. This is what you are saying. Absolute difference is very less by the see delta is a small quantity here. So you want probability that absolute difference between this theta at minus theta is less than this quantity. So you want this whole quantity, this whole probability as very large, right? Because probability of a sure event is one only, correct? So large means, suppose this is something 0.99. So this means what? You are saying this absolute difference is less than it is less than very small quantity, right? And we know probability of a sure event. You are sure about this. You are sure that absolute difference is very less and probability is large. Are you getting the idea?
Yes, sir.
Okay. Now, another thing is called bias. We have defined the bias of estimator. How will you find the bias of estimator? So, bias is defined as it is nothing but expected value of the error. And what is the error? Error is nothing but expected value of theta at minus theta. And we know what else can I write here? Expected value of theta hat minus theta or not? Because expected value of x minus a, I can write as a expected value of x minus a, because theta is a constant here, correct? So
Yes,
this
sir.
is the definition of bias. So see, bias and all these are very important. Now, if I'm saying bias of this theta hat is 0, okay, then I will say the theta hat is an unbiased estimator. Okay, this is not biased because bias is 0. Okay, I will say this theta hat is a unbiased estimator of theta. Okay, so how will you find this bias 0 or not? So if bias is 0, this means I can write expected value of theta hat minus theta equal to 0.
Yes, sir.
So this means what? Can I write expected value of theta hat equal to theta? Right?
Yes, sir.
So this is what? So if your expected value of estimator is equal to the parameter, then I will say theta hat is an unbiased estimator of theta. Okay, are you getting?
Yes, sir.
So okay, if question is, suppose there is a question, it will ask you to find the bias of estimator, then how will you proceed? So bias, what you have to do, you will find the expected value of theta hat and you will subtract with the original this quantity. I'm going to highlight with red color. So this quantity will help you to compute the bias of the estimator. Suppose this quantity, if you subtract expected value of theta hat minus theta is coming out to be 0, that means what to say, that estimator is unbiased. So usually you have seen, already we have seen, so expected value of x bar is equal to mu. Okay, this means what? This sample mean, if I'm writing like this, so this sample mean is an unbiased estimator of population mean. Okay, are you getting? So this population mean, I'm talking about distribution mean, I mean the samples from where you have drawn your samples. Okay, the population, is this clear?
Yes, sir.
Okay, great. We will see some questions. I have collected some questions regarding this and all. Okay, so we will see those part. So next thing is called variance of theta hat minus theta. Okay, I mean variance. What is the variance of error? So if I will ask what is the variance of error, so what else can I write? Can I write this is same as variance of theta hat? Because theta is a constant and we know variance, if I would like to write variance of x minus a, this is same as variance of x. Yes or no? Because adding or subtracting a constant doesn't impact the variability,
Yes, sir.
right? This is something we have seen. So always you can write variance of theta hat minus theta is same as variance of theta hat. Theta hat is the estimator. It can be x bar, it can be x1 minus 2, x2 divided by 2, anything, just a function of the samples. Okay. Next thing in the, so okay, so these all things are very very important. Okay, so this bias part, variance part, risk part, these are the very very important for your end term. And how you will define the risk actually? So risk of estimator is nothing but defined as the expected value of theta hat minus theta whole square. Basically this is expected value of, I can say expected value of error square. Okay, so what is the another name for this? Anyone can recall and tell me?
Mean squared error, sir.
Mean square error. Okay, so sometimes this risk is also written as MSC, right? Mean squared error. So you can see the how name has been, defined here. So what is this? Square mean, this is expected value, square of what? Error. Okay, this is the nomenclature is there. Okay, so another thing, what is the relationship? I'm not going to do in the derivation. You can check. Anyway, derivation is not important here, as per the as at least for this class. Okay, so risk is nothing but I can define when you will expand this part. So risk is nothing but bias square plus variance of, I mean variance of theta hat, I mean variance of this that particular
Error.
part, error. Yeah, and yeah, you can say error or variance of the estimator. Okay, so if there is a question, it is asking about you to find the risk, then what you have to do? You have to calculate the bias of that estimator, you have to calculate the variance of that estimator, then you will do square of that bias and you will add with the variance. Okay, so here you can write like this also. This is same as if let me write in formula. So this is something I can say bias is square. So bias of that estimator, okay, plus variance of theta. Okay, so this is the relationship which is again I will say this is very very important. You have to keep in your mind. Okay. Now, next thing is okay. So far, it is okay to all of you. Are you able to quickly recall and all? Yes or no?
Yes, sir.
Yes.
Okay. Oh, great.
Hello.
Yes.
Sir, actually, I want to ask one thing. It is
Hmm?
related to unbiased, sir. Sir,
Hmm?
in practice assignment, there is one question in which summation of xi and summation of x square is given,
Hmm?
and n is also given. And they ask
I will
unbiased
come.
variance.
I will come to that part. Okay. So
So it is
let's
related to
focus. I will come to that part. I'm not denying to giving the answer for that. What I'm saying, let's first focus our agenda of the session. Let's be in a standard form. Then we will discuss. Okay. Just
actually
tell me
what
till
I'm asking is it is related to unbiased concept. That's why I'm asking.
I will come to that part.
Okay,
See,
sir.
I'm not denying your query. So my concern is let's be in a standard form of the session. Let's
Okay.
discuss quickly cover the concept. We will see the questions of from the PYQ and then I will come to that part. Okay.
Okay, sir.
Okay. So till now the concepts are okay. Whatever the things we have discussed. Okay. Yes. No.
Yes, sir. Yes,
Yes,
sir.
Okay.
sir.
Are you able to recall? Okay. Great. Okay. Give me 1 minute. Give me 1 minute. Just opening. Let me open the PDF so that no, we can discuss the questions. So should I finish the concepts first? I mean, all the method of moment and MLE, then we should discuss the or should we try to solve the questions from bias estimation, whatever the things,
First finish the theory, sir.
Yes, sir.
all
Yes,
MLE,
yes.
MME,
Yeah, sir, 9 and
right?
10.
Or should we proceed like this? I mean, should we whatever the concept we have discussed till now?
We are discussing the questions and then we will proceed
Okay,
to.
okay, all right, no problem. Then let me finish. I was just
Okay.
I was
On
thinking to discuss the concept, whatever we have discussed. But anyway, let's try to finish the theory quickly. Okay. Anyway, we have only two topics are left there.
sir, on every concept, give the one example during the when you're discussing the concept. It will
Sure,
be
sure.
better understanding. Provide the better understanding.
Okay, okay,
So
okay.
I
Then
was
let's
thinking we can solve some questions and then we can proceed to week 10 like this.
okay, okay. Let's see. Let's discuss these questions itself. Okay, whatever the concept we have discussed. Okay. Now, if you see this question, so question this is asked. I don't recall the exact term, but this is in one of the previous term. So suppose x1, x2, x5 are IID samples from distribution X with unknown mean mu and variance sigma square. There are three estimators for mu has been given. So mu1 is defined, mu1 hat is defined like this, mu2 hat is defined like this, and mu3 hat is defined like this. So if you see the options, we have to check whether this is unbiased or biased, right? So first of all, see why we are moving to this estimation part. In lots of cases, in when you will enter into real life scenario, sometimes you don't know the value of the parameter, and we have to estimate. And how we can estimate? We can estimate with the help of the samples. Correct. Now it is asking about unbiased and all. Then we know how to check the unbiased property. We know how we have defined the bias. So bias is defined as a expected value of theta hat minus theta, right?
Yes, sir.
So what we will do, we have to check expected value of mu1 hat minus mu,
Equal to
right?
0.
Right. This is not compulsory, but we have to check whether no
Yes.
equal to zero. You see,
For
you have to
unbiased.
calculate this value. Let me finish. You have to calculate this part. If this is coming to be zero value of this, then you will say it's unbiased. Okay.
Yes.
there you shouldn't put 0 directly.
So we can
Okay,
also check na, if U of mu1 gap is equal to mu, then it is unbiased.
then it unbiased. Then how will you define? First of all, see. Okay, if see, if you are going with like this, you are correct. I'm not denying. If
Yes.
you are going like this, you will get whether it's bias or not. I mean, you will get the bias of that estimator also. Okay,
Yes. Yes.
so we will cross check this part. All right, okay,
Okay.
along with uh, and then this part we have to check for other estimators also, like similarly expected value of mu2 hat minus mu2, expected value of mu3 hat minus mu3. Okay, so let's say so option A and C are correct, but let's cross verify. So expected value of mu1 hat, okay, minus mu. Okay, let's do like this. First of all, let's calculate expected value of mu1 hat. So if you calculate here, then what you will get, 1 upon 5 you can take outside. It will be
Yes.
expected value of x1 plus expected value of x2 plus
X2.
so on plus expected value of x.
X5.
And this is nothing but 1 upon 5. What is the expectation of each xi? This is mu only. Mu plus mu plus mu plus mu plus mu 5 times. So it will be 5 mu divided by 5. 5 is going to cancel. It is mu only. So we
Yes, sir.
got expected value of mu1 hat is nothing but mu. So this means option A is correct. Mu1 hat is an unbiased estimator, right? So this is same as expected value of mu1 hat minus mu is 0. Understood?
Yes, sir.
Now we will check for the mu2. So if you see for mu2, so expected value of mu2 hat, so this is nothing but expected value of what is this, x1 plus x2 divided by 2. So x1 plus x2 divided by 2 plus I can write expected value of x3. All right, so it will be 1 upon 2 expected value of x1 plus expected value of x2, and this is another term plus expected value of x3. Now this will be 1 upon 2. It's a mu plus mu into 2 mu, right? And expected value of x3 is mu. So this is 2 mu. You can see this is not 0. I mean, this is not, basically this is not equal to mu only, right? So this means what? Mu2 hat is a biased estimator.
Biased.
Yes, sir. Biased.
This is not unbiased, right?
Yes.
So
Yes,
this
sir.
means option B is not correct. Okay, you can okay, suppose I will ask what is the bias, how much bias, then what you will do, expected value of mu2 hat minus mu, this is something will tell you the bias, right?
Yes, sir.
So
Mu
this will be what, 2 mu minus mu, so there is bias of mu.
mu.
Yes,
is,
sir.
is, is this part clear? So that's why I was uh, emphasizing to proceed like this, but anyway, either approach is correct, that's not a problem. Okay, so we'll check for this mu3. So if you see expected value of mu3 hat is nothing but if you take 2 times expected value of x1, so this will be 2 times mu plus mu divided by 3. This is nothing but 3 mu divided by 3. So this is mu only. Again you can see mu3 hat is unbiased. So
Hmm.
that's why option C is correct. Is this clear?
Yes, sir.
Yes, sir.
Okay. Now I will quickly discuss this question number 2 also, which is similar concept. So if you see, suppose x1, x2, x5 are IID samples from distribution X with unknown mean mu and variance sigma square. We don't know mu. We have to estimate, and we will estimate with the help of estimator. So mu hat is defined like this. It's the estimator of mu. You have to find the value of k such that bias is 0. It is given that it is unbiased. Then you have to find the value of k. Okay. So would you like to try? Everyone has pen and paper.
Yes, sir.
Yes, sir.
Can
We
you
will
try?
try.
Okay, just
Yes.
try it for 2 minutes.
Yes, sir. It is 7.
It is 7, right?
Yes, sir.
So everyone is getting. So see, bias is equal to 0. This means what? This means expected value
E
of mu hat minus mu is equal to 0.
0.
This
Yes.
means I will say expected value of mu hat equal to mu, right? So this is mu. So expected value of mu hat means it will be 2 times of expected value of x1 plus expected value of x3 plus k times expected value of x5 divided by 10 equal to mu. So this is 2 mu plus mu plus k mu equal to 10 times mu. This is 10 mu, right? We have to
Yes.
find the value of k. So this will be k mu is equal to 10 mu minus 3 mu, which is 7 mu. So from here we can say k is 7. This is how simple it is, right?
So
Now
this is
Yes, sir.
the next,
condition for condition when mu will be bias.
sorry,
This is the condition for bias. Hello, sir.
yes. Yeah, what is your question?
Means, sir, when we check for biasness, then it should not come as expectation of ex1 minus mu equal to should not be equal to 0. No, the mu value of mu should be a multiple of something, multiple of mu, not.
This is given already. That this information I'm using from the question itself. Are you getting? So I'm already saying bias is 0. You have to find the value of k. For what value of k it is unbiased? Okay.
Okay. Oh, sir. Okay.
So please read the question carefully. This is the basic mistakes people are making during the examination. Anyway, so next question is, suppose x1, x2, xn are IID samples from a distribution x with an unknown mean mu and variance sigma square. Again, mu1 is an estimator of mu such that you expected value of mu hat is given to you 2 mu plus 3. And another estimator mu2 hat is defined like this. Okay. So you to find the value of k for which mu2 hat will be an unbiased estimator of mu. See, mu1 hat is not unbiased, right? You can see expected value of mu1 hat is something, right? But you have to find the value of k such that mu2 hat is unbiased estimator. So the key information is this. So if I'm saying mu2 hat is unbiased estimator of mu, this means bias of mu2 hat comma mu is 0. What does this
yes,
mean?
sir.
This means expected value of mu2 hat minus mu should be equal to 0. This means I have to do expected value of mu2 hat equal to mu. Till now, is it clear?
Yes, sir.
So we have
Yes,
to
sir.
use the information. Now, what is the expected value of mu2 hat? So this is mu1 hat minus k divided by k
Minus.
minus 1 equal to mu.
Yes,
All
sir.
right. From here, what else can I write? I can write 1 upon k minus 1 I can take outside. In the numerator part, I can write expected value of mu1 hat minus k. Yes or no? Yes
Yes,
or
sir.
no?
Yes, sir. Yes, sir.
Right. Yes, sir. And if you see in the question itself, expected value of mu1 hat is given to us as a 2 mu plus 3, right?
Three.
So it will be 1 upon k minus 1. It will be 2 mu plus 3 minus k equal to mu. Would you agree with me?
Yes, sir.
Now, what else
Yes.
I can do? We have to solve this. So 2 mu plus 3 minus k. This k minus 1, if we will take to right side,
Two
it will be
times.
k mu minus k. And from here, you can clearly see this
Mu,
k
K.
will get cancelled out.
No, sir. K.
Sir, it is.
K minus
Yes, sir.
Oh,
RSS.
correct.
If,
Sorry. 1 second. Yeah. Sorry. Mistake. Calculation mistake. So it's a k mu minus mu. Now what we will do? We will do 2 mu plus 3 equal to k mu plus k. Is this fine now?
yes,
So
sir.
from here, what is this? This is 3 mu plus 3, and this is k I can take common. This is mu plus 1. And from here, 3 I can take common. This is mu plus 1. What is the value of k here?
Three.
3. So from here, we can say k is 3. You can see how simple it is, right?
Yes,
So
sir.
k is 3. Now, next question is also based on this part only. So what you have to do, you have to check whether bias is 0 or not. So option A and C are correct actually. And you have to, from the options, you can see you have to find the variance and you have to check whether variance is, which variance of mu1 hat is less than or not. So you can just do, you can quickly try, okay? Let me do it anyway. So I will quickly cover. So what is the variance? I'm not going to calculate the bias, okay? I'm hoping it is fine to all
Yes,
of you,
sir.
right? You can
Yes, sir.
see this is 2 mu minus mu. Mu1 is just 0, right? And again here 2 mu minus mu plus 3 mu. What is this? This is
Mu.
mu only, right? Because 3 mu minus, so you will get 2 mu. But this is option B is incorrect. This should be equal to 0, right? So what is the variance of mu1 hat? This means variance of x1 plus x2 minus x3. So this would be variance of x1 plus variance of x2 minus variance of x3.
No, sir.
Yes.
Plus.
Plus. See, this will be minus 1 square, okay?
Yes, sir.
And it
Yes,
will
sir.
be 3 mu, right? Oh, sorry, not mu, 3 times sigma square, okay? Because this all are IID. Now, if you check variance of mu2 hat, then what is this variance of 2x1 minus 4x2 plus 3x3? Okay, then what is this? It will be 4.
Times.
First of all, it will be variance of 2x1 plus variance of 4x2 plus variance of 3x3. And if you solve this, it will be 4 times of variance of x1 plus 16 times of variance of x2 plus 9 times of variance of x3. So it will be 29, right?
29.
29 times of sigma. So you can quickly see
Sir, can you
variance of.
explain the symbol, sir? Like
Sorry?
y minus is become plus.
I think this is something I shouldn't discuss, right? I was assuming this is very clear to all of you. But anyway, I will discuss. That's not a problem. So the thing is, this basic thing, I think it's very useful to keep in your mind. See, variance of x1 minus x2 is nothing but, can I write like this? Variance of, I will show variance of x1 plus minus 1 times of x2, correct?
Yes, sir.
Yes or no? Who asked this question? I mean, is this clear to you? This is fine?
Yes. Yes.
Right. And we know x1 and x2 are independent. Then can I write variance of x1 plus variance of minus 1 times of x2?
Yes, sir. I got it now, sir. Yeah.
Right. So it will be variance of x1. And we know variance of a times of x1 is what? A square variance of x1. Right. So it will be minus 1 square variance of x2. And this is nothing but variance of x1 plus variance of x2. Clear? This concept I have used. So you can clearly see it's a variance of mu1 is less, right? Because this is 3 sigma square and this is 29 sigma square, right? One more thing, if suppose there is a question, it is asking risk of mu1 hat, then what you will do? Tell me what is the risk? Bias is 0. So
Bias
0 square
variation.
plus 3 sigma square. So here risk is same, right? Similarly for risk of mu2 hat. Clear?
Yes, sir. Yes, sir.
Okay.
सर बायस हर बार जीरो होना जरूरी है क्या?
Uh, I don't know
मतलब
whether I.
जैसे mu1 कैप mu1 इक्वल बायस ऑफ mu1 कैप mu1
Okay,
इक्वल
okay. One second, one
or it
second,
should
one
not be
second, one second, one second. Did we get 0 here?
yes.
Yes. Are you seeing the screen? Whatever the screen I have presented, is it visible to you?
Yes visible sir.
Okay, so is the are we getting 0 here?
No
What is this? Bias?
bias.
Bias of mu2 hat? Did we get 0? No, right? This is not true always. That's what we are trying to say. If it is equal to 0, it is unbiased. Otherwise, there is some bias, right? Biasness is there. Understood? So how to calculate? See,
जब बायस जीरो हो जाएगा तब वो अनबायस होगा.
correct. That's what, right?
वो अच्छा सर समझ गया.
Okay.
Okay.
Okay, so the next concept is method of movement. So I will quickly go through this and then we will try to solve the question. So what is the method of movement basically? So x1, let's say x1, x2, xn. This is all our IID from x. Okay. Now, so we are defining, right? So these moments and all we have already discussed. But anyway, I will repeat the procedure. So this is this how we can define the sample moments. Okay, so sample moments we can calculate with the help of these samples. Okay, so in general it is defined as kth sample moment is as let's say mk x1 x2 xn. I mean with the help of this xi's, it is defined as nothing but 1 upon n summation of I is equal to 1 to n xi raised power k. This is kth sample moment. So in general you can write like this. But for one sampling instance, okay, so let's say for a particular sampling instance, so anyone, what do you mean by sampling instance? Means we are getting some particular, let's say you perform sampling one time, right? You are getting these possible values x1 x2 xn. What I mean by this, let's say I asked you to toss a coin 5 times. It is possible you will get value 1 1 1 0 1 1 1. Yes or no? First time. Next day again I will ask, suppose I ask you to toss a coin, then it is possible you will get the value 0 0 0 1 1. Yes or no? So
Yes.
for different sampling, you are getting different values. That's why we are writing small x1, small x2, small xn. I mean, these values can change. So this is one sampling instance. This is one sampling instance. So this is what? This one is what? Value of is x1. This is 1, x2, x3, x4, x5. Are you getting? So this is sampling instance. This is just a terminology. Don't worry about this. So if I would like to write the first sample moment, okay, then what it will be? So it's nothing but we can write as small m1 is equal to 1 upon n. So this is for kth. In kth, it's x raised power k. In general, for first sample, it will be x raised power 1, which is nothing but sample mean only. Yes or no?
Yes, sir.
And if I will say second sample moment, so second sample moment is defined as m2 is equal to 1 upon n. It will be summation xi square. Correct?
Yes, sir.
If I will talk about third sample moment, so it will be m3 is equal to 1 upon n summation of xi cube. So usually in our stats 2 course, we are dealing with just two parameters family. I mean, the distribution which has one parameter and two parameters. So to solve, see, anyway, what's our main purpose? Our main purpose is to estimate the value of the parameter, right? And this is method of moment is one of the method to find the value of this unknown parameter. Okay, so if you have one unknown quantity, only one equation is enough to find those value, right? If you have two unknown quantity, then you need two equations, right? So as of now we need only two moments. Okay, so what is the population moments and or you can say distribution moment? Okay, so this is defined for distribution. So what I mean by distribution or population, so from where you are selecting your sample. Okay, so this can be normal, Bernoulli, Poisson, or any x, any PMF, any PDF. It can be anything. Okay, so this parameters is all about. So we have seen from MGF chapter also. So expected value of x is nothing but called the first moment, right? And expected value of x square is called second moment, right? And similarly, expected value of x cube called the third moment, and so on, right? So we have seen, right? If you see, first of all, how will you calculate this expected value of x? So this is, we can
Yes.
calculate with the help of distribution. If x is discrete, okay, suppose x is discrete, then how will you proceed? You will calculate summation of x into px of x, right? If x is continuous, then how will you proceed? You will integrate x square, sorry, x fx dx. Yes or no?
So X
For
into.
this part,
Yes.
yeah, x into fx dx, right?
Yes.
Now if you have to calculate expected value of x square, then it will be x square, and again it will be x square as usual. Yes or no?
Yes, sir.
Correct. Now, what is the procedure in method of moments actually? So what you have to do, as I told you, if you have to estimate, let's say I'm saying x1, x2, xn has been drawn from Poisson distribution with parameter lambda, and lambda is unknown. So lambda is unknown and there is only one quantity. So to estimate one quantity, we need only one equation, right? So I can write here for one parameter theta, we need only one equation, that is sample moment. What I will do, sample moment m1, I will equate with the distribution first population moment, distribution moment. Okay, so this has been proved with the help of, weak law of large number and central limit theorem. This is true. I mean, we are equating this sample moment to the distribution moment or population moment. And what is this m1? And we have seen m1 is nothing but 1 upon n summation of xi equal to expected value of x. So this is something we have to calculate with the help of sample, and this is something we have to calculate with the help of distribution or population. Now, if you have two parameters, okay, so for two parameter actually, so to find the two unknown quantity, how many equations we need? We need two equations. So I will do m1 equal to expected value of x. I will equate first sample moment to first distribution moment, and next I will do I will equate m2 is equal to expected value of x square. Okay, so by using these two equations, what I will do, I will calculate the expected, I will calculate the unknown parameters. Okay, so let me take one example, then I will move to the uh, questions. Okay, so let's say I'm saying x1, x2, and so on xn. This is IID x. Okay, and let's make it Bernoulli p, and this p is unknown and we have to calculate. So to calculate this unknown p, we need only one equations, right? So what I will do, tell me, I have to equate m1 equal to expected value of x, right? Now let's try to understand what is this expected value of x. So this expected value of x we have to calculate from the distribution. So what is the expected value of x here? Bernoulli distribution. What is the expected value of Bernoulli distribution?
P.
P only, right? And what is the m1? 1 upon n summation of xi. So you can see directly we got the value of p. So here p hat means we have find the estimated value 1 upon n summation of xi. For example, suppose you have been given like for 5 tosses, so you got the output 10011. Now tell me, so this is your x1, this is your x2, this is your x3, this is your x4, this is your x5. So what will be the value of p hat here? So for this it will be 3 divided by 5. Understood?
Yes, sir.
Okay, great. Now this is for one parameter. If you have, let's say, two parameter family, let's say gamma. Okay, I'm saying x follows gamma distribution with parameters alpha and beta, and both are unknown. We have to estimate. Then how? See, if you have two unknown quantity, as I told you, we need two equations. So what I will do, m1 equal to expected value of x and m2 equal to expected value of x square, right? And what is the expected value of x in case of gamma distribution? This is alpha by
Beta.
and okay, how will you find the expected value of x square? What is the variance of x?
Sir, alpha by beta square in case of
Alpha divided by beta square, right? I think
yes.
you can cross check whether it's correct or not, but I think it's correct. But from
Yes.
here only you can see what is the variance of x. Expected value of x square minus expected value of x whole square. This is defined as alpha by beta square,
Yes, sir.
right? And what is the expected value of x square? You can find alpha by beta square and expected value of whole square. That means alpha square beta square. So you can substitute here m1 equal to alpha by beta, and you can find something, let's say alpha equal to beta times of m1, and m2 you can put like this, alpha by beta square plus alpha square divided by beta square. Then how you can do? You will proceed like you can substitute alpha equal to beta m1, then you can find and you will get something, some with the some equations, right? And at the end what you will do, you will find the value of, let's say here, if you are substituting here, you will get beta hat, and if you substitute the beta hat, you will get the alpha hat. And m1 is nothing but 1 upon n summation of xi, and m2 hat is m2 is 1 upon n summation of xi. So this is something you can calculate from your samples, right? Now let's try to discuss the questions. Okay, is this clear? Method of movements, some, okay.
So could you take some questions on these topics? Method of
That's
movement.
what I told you, right? Just give me a minute. So this is one of the question which is asked in one of the previous term. So suppose the time taken by a delivery service to deliver a package in hours follows an exponential distribution with parameter lambda. The timings in hours from a random sample of 6 deliveries is given to you. Okay. Find the method of moment estimate of lambda for the given sample. Okay. So it is asking method of moments lambda. Method of moment estimator. So first of all, okay. So this is your x1, x2, x3, x4, x5, and x6. Yes or no? We have been given information x follows exponential lambda. And how to proceed? We know there is only one parameter. Tell me, what should I write? m1 equal to expected value of x.
Yes.
Right? Now, what is the expected value of x in case of exponential distribution?
Lambda.
1 by lambda. What is the m1? Summation xi divided by n.
Yes.
Okay. Let's do in general. For now, let's do in general. So what is the value of lambda hat will be? n divided by summation of n, summation of xi? Yes or no?
Yes, sir.
That's what. And what is the value of n here?
So n is
6.
equal to 2 for 6.
What
6.
is the value of summation of xi? That means we have to do 15 plus 20 plus 15 plus 16 plus
100,
14
sir.
plus 20, right? So you can cross check. So it will be 6 divided by 100, right?
Yes, sir.
So which is what?
6.
0.06. So you can see 0.06 is the answer. Is this clear? You can see very
Yes, sir.
simple this question is, right? Now,
Yes.
let me come to the next question. Yeah. So you can see this question. In this question, it is not mentioned the samples have been drawn from any specific distribution, any standard distribution, right? PMF is given to you, okay, and you have only one unknown quantity which is theta. You have to find the method of you have to find the estimate with the help of method of moment, right, for theta. And these are the exercise, right? How many samples? X1, X2, X3, X4, X5, 6, 7, 8, 9, 10. 10 samples is given to you. So this kind of questions is important actually. Okay. Now, if you have only one unknown quantity, how will you proceed? I will do M1 equal to expected value of X. And this is what? Distribution moment, right? And this expected value of X I have to calculate with the help of here, right? So let's make
Yes.
it equation number 1. And what is the M1? M1 is what? 1 upon N summation of Xi, right?
Yes.
And this is what?
Yes,
This
sir.
is I can calculate with the help of these samples only, correct? Our main focus should be expected value of X. See, in the previous question, it is given as it is from exponential lambda. Then we know expected value of exponential lambda is 1 by lambda, and I can directly find the mean, right? But here it's not. We have to calculate the expected value of X. What will be the expected value of X here? Tell me. It will be 0 into
0
2
into
theta
2
by
theta by
3
2.
plus 1 into theta by 3 plus 2 into 2 times 1 minus theta by 3 plus 3 into 1 minus theta by 3,
Yes, sir.
right? So what is the case here? It will be 0 plus theta by 3 plus 4 minus 4 theta by 3 plus 3 minus 3 theta by 3. So you can see in the numerator part will be 437 minus 6 theta, right? Yes or no? 7 minus 6 theta divided by 3.
Yes, sir.
Yes.
So this is expected value of X. So this is something we got. Now, what we have to do from the equation number 1, we have to equate 1 upon n summation xi as a expected value of X. So what are the values? Our values is we have to add these whole things, right? Yes or no? So it will be 1
Yes.
plus 0 plus 1, 2,
13.
4, 6, 9, 10, 12, and 13. 13 divided by 10. So from equation 1, everyone is getting right?
Yes, sir.
M1
Yes,
equal
sir.
to expected value of X. So this is 1 upon X summation of Xi equal to 7 minus 6 theta divided by 3. And this is something from sample. So this will be 13 divided by 10 equal to 7 minus 6 theta divided by 3. So this will be 1 upon 1.3 equal to 7 minus 6 theta divided by 3. From here, it will be 7 minus 6 theta equal to 3.9,
9.
right? So 6 theta will be what? 7 minus 3.9, which is nothing but 3.1.
Yes, sir.
So 6 theta is nothing but 3.1, and you can say theta at is what? 3.1 divided by 6, which is 0.5
Yes.
2 something, right?
Ha.
Yeah, so 0.52 is the correct answer. So you can see, right? Now, are you able to relate the formula?
Yes.
Okay.
Yes, yes.
Okay, great. Now, there is another question with the help of method of movement. I think there should be some question. I think that you can try, right? I'm just leaving you as a homework because this is same. Just this is P
Yes,
and
yes, same.
some different. I think I'm hoping
Yes,
you'll
sir.
be able. Okay. So the next concept is max
In
MLE, right?
this question, range is also derived. How to derive the range?
That's for our references. That's not for your reference. You have to enter the answer that only.
Okay, okay,
Okay.
okay.
If your answer is coming within the range, it will be correct. Otherwise, it will be incorrect. Okay.
Okay.
It will be inbuilt in system, but not for you. I mean, it's if it's decimal points, right? If answers is coming in decimal point, then it's Okay. The next concept is called MLE. So what is the MLE? MLE stands for maximum likelihood estimation problem, right? So this is maximum likelihood estimation. All right.
Yes, sir.
So MLE, and what is the likelihood we have discussed? So I'm not going into too much depth, but let me quickly cover because we have to cover the week 10 also. So likelihood nothing but you are interested to know what is the chance or what is the probability of observing your, well, basically I will say observing my samples, right, for a given theta, right? So that's our key things. I mean, I'm interested to know what is the probability of observing my samples, right? Let's say x1, x2, xn for a given theta. This is something called likelihood. Okay. So how you can calculate the likelihood of a sampling? Let's say I would like to write likelihood of a let's say particular sampling x1, x2, let's say so on xn. This is for a particular sampling. So this definition is like, I mean, its notation is L x1, x2, xn. Okay, this is nothing but, so you are interested to know probability of observing your samples, means fx of x1 into fx of x2 into so on fx of xn. Okay, so in general I will write I product of I is equal to 1 to n fx of xi. So this can be discrete and this can be continuous also. I mean, if it's discrete, you have to use the PMF. If it's continuous, you have to use the PDF form, right? The next thing is in likelihood form. Actually, how will you find the maximum? We have to differentiate with respect to, let's say I'm talking about theta. We have to differentiate with respect to theta. We will equate to 0, and then we will find the second derivative, and then we'll see whether it's less than 0. That's the property of find the maxima, right? But here if you will multiply these all things, right, so it's possible you will get some, difficult quantity here, right? Suppose you are getting some, in exponent, some different difficult equation. This is sometimes it's very, complicated to find the derivative and all. So there is one concept in mathematics actually. What's the that maximizing the likelihood is same as, I mean, maximizing a function is same as maximizing the logarithmic of that function, right? So the same concept we will use, that is maximizing this likelihood. This is same as maximizing the log likelihood. Okay, so this is basically natural logarithmic.
Sir, this is for
Okay.
unknown parameters, na?
Yeah, this is another method to find the unknown parameter. So we will estimate. Okay, anyone can you tell me what is the meaning of this making del of f d theta equal to 0? What is meaning?
Partial differentiation.
The partial derivative को zero किया है आपने.
Yeah, that's. I'm not asking the what is the interpretation of this. Why
Slope
we are
is
making
zero.
this equal to 0?
Showing
Basically, we are
maximum.
we are interested in maxima, right? So suppose your function is like this, right? Then the slope should be 0, right?
Yes, sir. Course.
Okay, at this point, right? So that's what we are. This is the meaning of this part. D of divided by d theta equal to 0. We are not going to mathematics. I'm just giving the
Sir,
idea.
second derivative should be
Second derivative should be less than 0, because if
less than
see
0.
if this is the maxima, and you can see this should be less than 0, right?
Yes.
Only then this is the maxima. Yes or no?
Yes.
Okay. So this is slope. You have to make it as 0. Okay, so now, so what you have to do, you have to find the likelihood, then you have to find the log likelihood, which is natural log you have to take, and then you have to do the usual procedure. So I will take one general example, then I will proceed in general. Okay, so the same example I will take which I took in open session. So let's say I'm saying x1, x2, so on xn. This all are IID Bernoulli P. Okay, and P is unknown. So it will be clearly mentioned whether you have to find the estimate of P with the help of method of moments or with the help of maximum likelihood estimation. Okay, suppose samples have been given to you, small x1, small x2 up to small xn. For example, sorry. So I'm saying 1, 0, 0, 1, something like 1, 0, 0. Okay. Suppose in this, I'm saying out of n, W times 1 is coming. Okay. W times 1 occurs. This means how many times 0 will occur?
W minus
W minus n or n minus w?
N minus 2.
See, if you have 1, 1, 0, 0, I'm saying 3 times 1 is occurring. That means 5 minus 3, 2 times 0 is there, right? Very basic concept. Okay. Yes, no, is this clear?
Yes, sir.
Yes, sir.
Okay, all right. So do let me know if you are not getting any point. So what is the likelihood? I told you likelihood nothing but product of fx of x1, fx of x2, and so on, fx of xn. So
XN.
let's say w times you are getting 1, that means it will be p into p into p, right?
Yes.
W times, right? And we have to multiply the probability of 0 also, right? 1 minus p, 1 minus p. How many times?
N
Double
minus 2.
times.
N minus
N
w, right?
minus
N minus double time.
See, in Bernoulli, p is for 1 and 1 minus p is for 0, right? Now, if you see, this L is coming as a p raised power w into 1 minus p raised power 1 minus w. See, now here in this equation only, if you want to find the derivative, if you want to find the, I mean, basically differentiate with respect to w, it's a bit difficult task, right? I mean, at least here. So what we will do, we will take the natural log. So what you will get? So log of p raised power w plus log of 1 minus p raised power n minus w. So by using the logarithmic property, it will be w times log of p plus n minus w times log of 1 minus p. Would you agree with me or not?
Yes, sir.
Right? So we have to differentiate with respect to what?
P.
P, because we have to
P.
find the estimate of P, right? We have to maximize the P. So this will be W by P, because differentiation with respect to basically d of dx log of x is what? 1 by x only.
Yes, sir.
So this will be, and this will be n minus W divided by 1
N
minus
minus
P,
2.
and we have to differentiate 1 minus P again. So it will be
Minus 1.
minus 1.
Minus
So
P.
what we have to do? We have to do equate with 0, right?
Yes, sir.
So what we will get here from here, it will be W by P minus n minus W divided by 1 minus P equal to 0. So this is W by P equal to n minus W divided by 1 minus P. Yes or no? Now it will be W 1 minus P equal to n minus W P. Yes or no? Basically, we have to solve this. So this will be
Yes, sir.
W minus WP equal to NP minus WP. So from here, WP, you can say it's cancel out. So what we will get? W equal to N times of P. So what is the P hat? P hat W by N. So what is the W? Means number of ones and divided by N. Is this clear?
Yes, sir.
Yes.
Okay. Okay, great. Then let's see the some questions for this likelihood. Emily. Okay. Okay, let's try to solve this question. So this question says the amount of time in minutes a postal clerk spends with a customer follows an exponential. Give me a minute. Okay, so in this question, it is says this information this postal clerk spends with a customer follows an exponential distribution with parameter lambda, right? And the timings in minutes from a random sample for 5 customers is given to us like this. You have to find the maximum likelihood estimate of lambda for the given sample. So what should I do? Tell me, how will you proceed?
We basically
First,
write
we
the
have to find likelihood.
Yeah, so I would suggest to do in general first of all. Okay, if you are doing in general, it will be helpful for you. Okay, so let's say in general. So what is the first of all? It says x follows exponential lambda, right? Let's in general means do for n and just substitute the values at the end. So what will be the likelihood? It will be lambda L equal to product of I is equal to 1 to n fx of xi, right? Just okay. So what is the product? It will be I is equal to 1 to n. What is the PMF? Sorry, PDF.
Lambda is
Lambda
minus lambda x.
2 raised to power minus lambda times xi.
yes.
Yes, sir.
Basically, what is the case here? You will write likelihood as a fx of x1 into fx of x2 and so on. You will write fx of xn. So this for fx of x1, it will be lambda into e raised to power minus lambda x1 into lambda into, give me a minute. So next thing will be lambda into e raised to power minus lambda x2 and so on, lambda into e raised to power minus lambda x, right? That's this the same thing I have written here in general, right? Is this clear? The notations and all. Okay.
Yes.
So what
Yes.
is the things you will get? So it will be lambda raised to power n, because you are multiplying lambda n times. You can see, right? And what you are doing, e raised to power minus lambda x1 into e raised to power minus lambda x2 and so on, e raised to power minus lambda xn, right? So if you see, can I add power lambda raised to power n into e raised to power minus lambda x1
X1 plus
minus
X2.
lambda
Yes, sir.
x2 minus up to minus lambda time
X1.
xn, right? So from here, it will be lambda raised to power n into e raised to power minus lambda times summation of xi.
Yes, sir.
Is this clear? Is this clear to all of you, right? Are you
Yes.
getting
Yes,
this
sir.
part? So the next task is we have to take log. So log we have to take. So it will be log of lambda raised to power n plus log of e raised to power minus lambda times summation of xi. And we know log with base e and e, this is nothing but one only, right?
Yes, sir.
And here we will get n times of log lambda minus lambda types of summation of xi. You will get log e of e, which is going to be 1, right? So this is n log lambda minus lambda times of summation of xi. Would you agree with me? This is log of L.
Yes,
So far
sir.
it is clear. What is the
Yes.
next task? We have to differentiate with respect to
Yes, sir.
lambda.
Lambda.
D of log L, d of lambda equal to n log lambda minus lambda summation of xi equal to,
Zero.
0.
sorry. We have to differentiate, right?
Differential n by lambda.
So if you will differentiate, it will be n
N.
by lambda minus summation of xi equal
Lambda.
to 0. Okay. See, the
Yes,
next
sir.
job you have to cross check whether second derivative is less than 0 or not. But I'm skipping here. So what is the part? It's n by lambda equal to summation of xi, right? So it will be lambda hat will be what? N by summation of. That's all. That's all you got. And you have to you have to check what is this value. 13, 10, 15, 13, 14. Okay. So your
55.
samples are 13, 10, 15, and 13, 14, right? So what will be your lambda hat? Lambda hat will be 5 divided by all this, right? Addition
65.
13 plus 3 plus, yeah, whatever. This is 65. So 5 divided by 65, right?
Yeah.
Yeah, whatever the value. So you will get this answer. Okay. Is this clear?
Yes, sir.
Okay. This was about your standard distribution. Now, if you see this question, this PMF of a discrete random variable x is given to you, and you have been asked to find the maximum likelihood estimate for these samples. Okay. So let me write first of all the distribution, because this is not about any standard distribution. Okay. So what is the value? What is the PMF? I think for, let me check. So
We
0,
can
1,
solve that.
2, 3, 2 theta by 3, 2, 1 minus theta by 3, 1. Okay. So x is taking value 0, 1, 2, 3, and what is the respective probabilities? So this is not any standard distribution. So this was 2 theta by 3, and for 2 it was 1, 2, 1 minus theta by 3, and it should be 1 minus theta by 3, because total summation should be equal to 1. Let me check. Oh yeah, correct. Now, if you see, then what is the likelihood for this? So likelihood was, likelihood is what? Fx of x1 into fx of x2. How many samples we have? 10, right? You can see here, right? I
Yes.
think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, just observe carefully here. So x1 is what? Let's say x1 is 3, right? This is x1, x2 is 0, x3, x4, and so on. This is x10. So you can see for 3, fx of x1, let's say. So what is the probability for 3? Observing 3,
1 minus theta by 3.
right? And into next task is 0, fx of x2. For 0,
2 theta by
2
3.
theta by 3, right?
We
For
can
1,
solve it, sir.
Theta by 3.
theta by 3. For 2, 2 1 minus theta by 3, right? I'm not going to write for all samples. I will do a smart trick here. If you see 3, how many times occur? 1 times, 2 times, right? So 2 times we have to multiply this property. Yes or no?
Yes.
So it will be square,
Yes.
right? How
Yes.
many times 0 is occurring? 1,
Two
2.
times
It will be
again.
2. How many times 1 is occurring? 1, 2,
3
Three
3.
times.
times.
How many times this is occurring? 2, 1, 2, 3. Is this clear now? Yes or no?
Yes, sir.
So now what we will do, we have to just take all constant together, because anyway, at the end, if you take derivative, it will be 0. So it will be, what are the constant? 2 raised square from here and 2 raised power cube from here, and divide by 3 raised power 10, right?
Yes.
Okay. Yes.
And what are the remaining things? So 1 minus theta whole square, theta square, theta cube, 1 minus theta cube.
One.
Yes, sir. So you can see the powers. If you add power, it should be total equal to 10, right? Because we have 10
Yes.
samples. Now, so this is, I'm just 2 cube, basically 2
Yes.
raised power 5 divided by 3 raised
Sir,
power
hello.
10. It will be theta raised power
Sir,
5. Yes.
basically, we can do the rest of the calculations, sir. We can do that, I think.
Yes, sir.
Okay, so you
The
mean you
rest.
want to stop me here?
Yes.
Sir, what I'm saying, we can do the rest of the calculation of these
Anyway, let me
questions.
let me do it quickly. Let's see. Okay, this is not a.
Okay,
It
sir.
will take 1 minute only. Okay. So what is the? We have to take the log, right? So log of this constant 2 raised power 5, 3 raised power 10, plus log of theta raised power 5, plus log of 1 minus theta raised power 5, right? So this will be log of this constant. I'm just skipping. This will be 5 log theta plus 5 log 1 minus theta. So what is the next task? We have to differentiate
Differentiate
with
equal to
respect to
0.
theta equal to 0. So this will be 5 by theta plus and log of a constant. So this will be 0, right? If you
Yes.
differentiate 5 divided by 1 minus theta. 1
Into
minus theta we have to
1
differentiate again, which is minus 1 equal to 0. So it will be 5 by theta equal to 5, 1 minus theta. So you can see we will get 5 minus 5 theta equal to 5 theta. Anyway, so this is nothing but we'll get 5 equal to 10 theta. So theta at is equal to 5 by 10, which is half. Okay. So you can also find, you will cancel 5 here and you can find the theta. This is not 1 minus 0, this is 1 minus theta. So you can see option number C is the correct option. Okay, is this clear?
Yes, sir. Yes.
Yes.
Okay. So
Could you
same,
please
same,
take,
same. Sorry,
sir, could you please take some questions from practice assignment 9?
I will come to that. Let's go with the standard procedure, right? I mean, suppose someone is watching it later, it should be in proper way. Okay. I told
Okay,
you
sir.
again and again, please, we will discuss at the end. That's not a problem. So see what I'm trying to say here, you should just follow the no basic approach. If you are following the correct approach and your calculation is correct, at the end you will get the correct answer. That will not give you an incorrect answer, but you have to be careful a bit. Okay, that's all. So for this question again, sample is given to you. Then if it will ask about maximum likelihood, then you can do right the same question, right? Similar way. Yes or no?
Yes.
Right? I'm
Yes,
I'm
we can.
leaving this question, okay, for you to try. Okay.
Okay, sir.
Yes, sir.
Okay. The
Yes, sir. No
next.
problem.
Okay. So week 9 we are done. So we will start for the concepts of week 10. Okay. So see this method of moment estimation and maximum likelihood estimation, these are the method of to estimate the unknown value of the parameter. Okay. There is another method called Bayesian estimation. Okay. So what is this Bayesian estimation actually? What is this Bayesian estimation? Okay. So this is one of the parameter estimation. See, we have seen two method, that was method of moments and MLE, right? So these were when our theta was constant, I mean the unknown value of parameter. But there is new concept in Bayesian estimation actually. That is what? Let me create a scenario. Suppose I'm saying x1, x2, xn. These all have been drawn or IID from Bernoulli P. Okay, this P is unknown to you. Now my question is, suppose you are an experienced analyst or data scientist or something. I mean, you have some experience. And first of all, what is this P? P is probability of getting success, right? Suppose
Yes.
based on your experience, based on your prior knowledge, based on your prior experience, what you are saying, you are making a statement that I believe that uh, this bias P, I mean, you are not saying is. Suppose if for Bernoulli, if you are saying this is unbiased, let's say tossing a coin, it will be half, right? But you don't know what you are saying. You believe that this bias P is somewhere close to one. Just a belief, right? Belief system. Okay, somewhere close to one. I mean, from your experience, you are saying this part. Okay. Now, or basically, you are saying what is this? This is just your, this is an idea or this is a thought from your prior experience, right? Or you can say this is just a belief, whatever, just these are just a different names. Okay, now what is the main question? So main question is, if is there, your main question should be, is there any principled way on it? Okay, for what, in which, okay, suppose I have believed, then in which I can incorporate, okay, just be with me, it will be clear this concept. Incorporate our belief along with the data. Okay, see, if you have some intuition, if you have some belief, then to prove that you need some mathematical things, right? Okay, along with data into our estimation process. Okay, so basically this is our, I would say this is our goal. Means you have some belief from your prior experiences, you have some belief, you have some thought. Now my main question or main goal is there any principled way in which you can incorporate your belief along with the sample data into our estimation process, right? We have to estimate the our parameter, right? So what I mean by this P is somewhere close to one means you don't, you have just prior experience. You are saying P is somewhere close to one. This P can be something like this. Suppose this is zero. Sorry, this is one and this is zero. You can say P is somewhere close to one here, right? It can be here something like this, zero, one. It can be something like this. Sorry, here. It can be something like this. Yes or no? P can be in between here to here. Right? It can be anything, right? It's not a fixed here, right? This is something, a random variable. This is not fixed. Are you getting my point?
Yes.
So because you don't, you have just idea this is close to one, but you don't know, right? The so that means what we are doing, that is we are treating, I mean we have to treat, we are treating this belief, okay, as random variable, okay, which has some distribution. If this is the random variable, then it will be having some distribution. Yes or no? If it's a random variable, okay, associated with it, okay, it can be anything. I mean, you can say P is close to one, then you can say P follows, uniform with values. Let's say is close to one, then you can say something, anything. You can say 0, 1, or anything, right? P is lie between 0 and 1. I mean, we have to define the range accordingly. So what you are going to do, you are going to treat your belief in as a random variable. Okay. So what's the next task? So whatever your belief is there, right? Whatever your prior experience, that's what you are going to do. I'm going to codify this using a prior distribution. Okay, theta. Okay, so let's say I'm saying P theta. So P theta is nothing but prior information. Okay, whatever the prior information you have, or else you can say prior distribution. Okay, now, so what is the main task? Okay, so main task is nothing but whatever the prior experience, prior information you have, with the help of data, what you are going to do, you are going to update my belief or your beliefs. Is the rough idea clear? Means what you are going to do, you have some prior information, with the help of data you are going to update your belief. So what is the meaning of update your belief? Means what is the probability of theta given that a data. Okay, this is something we have to find out. Okay, so this is called Bayesian estimation. Okay, so why this is called Bayesian? Because Bayes theorem has been used here. Okay, I will tell you how in a minute. Okay, is the rough idea clear? This is about Bayesian estimation. You have some prior information, you have to codify it. I mean, you have to find any principled way in which you can incorporate your belief with the help of data, right? So you will take the help of data and you will update your belief, right? Yes or no? Is the rough idea clear? Okay,
Yes.
so what is the main task? So what I told you, so this p theta we are denoting for the prior information, right? Means you have some distribution about your theta, right? Now I'm going to use data in between here, and I'm going to find the what is the probability of theta given that this data. Means I'm going to update my belief with the help of this. So this is called posterior distribution. Okay, so in Bayes theorem, in some books, you maybe you have seen what is this is the posterior probability, prior and all. So what this posterior represents, first of all, you can think a bit from here. So this posterior distribution, this represents the updated knowledge. Okay, updated knowledge or updated information about what? About, tell me,
Yes, sir.
about parameter theta, right? After observing the, tell me, what should I write the next term?
Data.
Correct. So after observing the data, so this is called posterior distribution. Okay, let me write the Bayes theorem, then I will come to that part, how to calculate this theorem. So maybe you have seen this Bayes theorem. Okay, so Bayes theorem is what? Suppose you have two events. So let's say something like this. So let's say this is B1 and B2. There is one event. This is called A. If I will ask what is the probability that A has been occurred and what is the probability that it's in B1. Okay, then what else you can write? I can write probability of A intersection B1 divided by probability of A. Yes or no? And this is something what? This is something I can write the numerator part probability of B1 into probability of A given B1 and divide by probability of A. Yes or no? So this is called Bayes theorem. Okay, this is Bayes theorem we have seen. Now what is the next task? Okay, if I would like to write in general, I mean, let's say I'm writing like this: probability of uh, B given A. Okay, then what else I can write? Probability of A intersection B divided by probability of A, and numerator part I would like to write as a probability of A given B into probability of B divided by probability of A. This is multiplication rule. Is everyone getting how this is, how
Yes.
we have written? Okay.
Yes, sir.
Now let's talk about here. So suppose I'm saying, okay, I'm going to treat this B as our parameters. Okay, just replace this. Parameters is theta. Okay, and A just treat as a data. Data means this x1, x2, so on. Xn is given to you. Okay, this is, suppose this is S I'm writing. Okay, so what is the task? What we have to do? We have to find the what is the probability of theta given data. This is something we have to calculate, right? We have to update our knowledge with for a given data, right? This means what? Probability that theta given S I can write or not?
Yes.
Correct. So what is this? I can write probability of S intersection theta divided by probability of S, and this will be probability of S, sorry, theta. What should I write? Probability of S or probability of theta? Probability of
As
theta, right?
given theta.
Probability of theta into probability of S given theta divided by probability of S, right?
Yes.
Also, you can observe one more thing here. Probability of theta into probability of S given theta divided by probability of S. So this is basically independent of theta, right? This denominator part. Yes or no?
Yes.
Because probability of observing your samples only, right? There is no, not any role of theta, right? Basically, this is something constant, basically. So probability of theta given that S, can I write this is proportional to probability of theta into probability of S given theta? Yes
Yes.
or no? Right? So what is this probability of theta given S, or else you can write probability proportional to probability of S given theta into probability of theta, right? So this is what probability of theta given data. This is proportional to probability of uh, S means what I took as a data, right? Data given theta into probability of theta. So from the prior things, can you tell me what is this? This is
This
posterior. So
intensity.
posterior distribution of theta is proportional to this is
Likelihood.
likelihood,
Likelihood
right?
into prior.
Likelihood. What is the probability of observing your sample? Likelihood times this is
Prior.
prior. So this is the key thing of posterior distribution. Okay. So posterior distribution is nothing but it's proportional to likelihood times prior. So this p theta is nothing but prior. This is likelihood. You can see p theta we denote it as a prior. So is the rough idea clear to all of you basically?
Yes, sir.
Right. So what is the case? You are going to observe your first of all, you will be having some information about some prior experience about your parameter. Okay. Then with the help of data, you are going to update your information. Okay. And for this, we have one principled way which is called Bayesian estimation. Okay. Is the rough idea clear? Okay.
Sir, one doubt, sir. Like
Hmm.
likelihood is a multiplication of all functions, right, sir? Fx1, fx of x1,
Correct.
and so on, fx of xn. But here,
Correct. Correct.
probability of data given the theta, is it same as like fx of x1 and so on, fx of
See, what
xn?
is the likelihood? I told you, right? So likelihood represents what? If you see the definition, key definition, likelihood, what is the meaning of likelihood? Likelihood nothing but what is the probability of observing my
Sam.
sample, right, for a given theta, right?
Yes.
And what is this? I have written here probability of data given theta, right? And what is the data? I told you, right? Just try to interpret the notation. Data is nothing but x1, x2, xn, correct?
Yes.
And what is the x1, x2, xn here? This is the sample only, right? So you are interested in what is the probability of observing your theta, observing your data, sorry, observing your samples for a given theta, right? And what is the meaning? How will you observe your samples? This is nothing but fx of x1 into fx of x2 and so on, fx of xn. All right, that's all. So this depends whether it's a discrete or continuous. Accordingly, we have to adjust with the PMF or PDF. Clear?
Yeah, sir. Thank you.
Sir,
Okay. Mhm.
sir. So basically, we can say that so posterior is basically the updated prior, right? After observing the data, we can
Updated
say.
plan. Correct, correct,
Okay.
correct. So you have some prior information, you have some prior experience. You
Right.
want to check, you want to just check, you want to your update the belief, right? If
Correct.
you see, you are saying P is somewhere close to 1, for example, right? You don't know. Then what you will do? You will observe some sample. Based on the sample, you will check whether in reality your P is close to 1 or not. Okay,
Okay.
suppose you, with the help of samples, you calculated P and you estimated P and P hat is coming out to be, let's say, 0.89. It's possible, right? And you can say this is close to 1. I mean, suppose P hat is coming out to be 0.92. This is again close to 1. Suppose P hat is coming out to, let's say, 0.21. This is not close to 1, right?
Okay. Got it.
So are you
Got it.
getting my knowledge? You have some
Yes.
prior
Yes.
knowledge.
Yes.
Okay.
Thank you.
So you have some prior knowledge, which is I'm denoting as a P of theta, prior information. Now you will be having some data, means You will be having some samples. Using these samples, you are going to update your knowledge or information or beliefs. Okay.
Okay.
Okay. So give me 1 minute. I will connect my laptop with charging point. Okay. Yeah. Thanks, Praveen. That's what I'm going to do. Yeah. Give me 1 minute. I'll bring my charger and
Hello. If I am not wrong, about 4 to 5 topics have been left for week 11, sir. No? Sir,
yes.
sir, almost 4 to 5 topics you have to cover in week 10.
No, there is only one topic, right? Bayesian estimation.
And sir, Bernoulli samples will beta prior with uniform prior and unknown.
So that are the different kind of distribution. Okay, I will give you some idea. That's we are not going. See, there are lots of prior. Okay, so I will give you some idea, right? How to solve the questions. Okay, the rest is your job, your practice part. Okay. Okay, so let me see. I think there should be some questions. Yeah, correct. So this is one of the question. Would you like to try or should I try this question and next question you can do? What's your thought? Should I do?
Yes, sir.
Sorry,
Sir, we would like to try.
you would like to try? Can you give a okay, Rishabh is saying next. So just give a thumbs up who want to try right now. And who don't want to try now, you can down thumbs up. You can use the okay. I think if you want to try, you have 2 minutes. Just solve it. See, do not tell me the answer from just by checking here. Okay, it's not any marks awarding and all. The key thing is you should get the idea. Okay, just be honest and try on your own. So I'll be back in 2 minutes. Okay. Okay. So are you getting this part or should I? Did you get option number C as correct? Am I audible, right?
Yes.
Yes,
Yes.
sir.
So you are still
So
trying?
doing it.
Okay, great. All right, no problem. Okay. Rishabh is saying he got the answer. Very good. What about others? So I will wait till 9, I mean 7:35. Are you getting or not? I think got only one response from Rishabh. Others, are you getting answers? Okay, okay, from 2, 3 people. Okay. Samantha, Divya Mujumdar. Okay, great. Okay, let's see. So what is the key thing? We know what is the posterior distribution. So posterior distribution nothing but is proportional to likelihood times prior. Okay. So in the question you can see question says we wish to estimate the probability P of getting number 5 on biased die using a Bayesian estimator. This is the information. So how will you define your x? X is a random variable x getting number of 5, right? Right. Now, see again, x here clear. A number of times 5 appears basically. X is there. Okay, so number of times 5 appears on the die. So how many toss is there? N independent 10 independent toss, right? And what is the prior distribution? So okay. So if you see, first of all, what is the x following here? Binomial with parameter n comma p. Yes or no? See, each xi is Bernoulli, right? X1, X2, till X10, each xi is Bernoulli, but I'm talking about all 10 independent tosses. So summation of xi, I is equal to 1 to 10. We know sum of n IIT Bernoulli is nothing but binomial. So it will be binomial 10 comma p. Would you agree with me?
Yes.
Yes or no? And what is the
Yes.
prior? So, okay, so let me write here x following binomial 10 comma p. And what is the prior? Prior, I mean, the prior information is p follows beta distribution with parameter 2 comma 2. All right. Now we know what is the posterior. We have to find the posterior distribution. So posterior distribution is nothing but proportional to likelihood times prior. And what is the likelihood? How many times one is sorry, here what is the success, right? In the previous question here, we were interested in, if you see, to calculate the likelihood actually, what is the success? Success is how many times one is occurring, and we saw it's a W times, right? So what is the success here? I'm interested in 5. So how many times 5 is occurring, right? Yes or no?
4
So if you
times.
see, out of 10 throws, it says 5 times, sorry, 4 times 5
Okay,
appear.
sir. So
So
W
that
is
means
4.
W is 4. Let's say P is occurring, I mean 5 is occurring 4 times. That means P into P into P into P, and remaining you are getting some other number, that is 6 times. Yes or no? So this means 4 times you are getting success, and remaining 6 times you are getting failure, right? Yes or no?
Yes.
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 And what is the PDF of beta distribution? If X follows beta distribution with parameter, let's say alpha comma beta, or you can say M comma N, then Fx is nothing but X raised power alpha minus 1 and 1 minus X raised power beta minus 1. So here you can see it's about P. So here P is my random variable. So it will be P raised power 2 minus 1 into 1 minus P raised power 2 minus 1. Would you agree with me, all of you?
Yes.
So what is the case? So this posterior distribution is proportional to P raised power 4 plus 2 minus 1 and 1 minus P raised power 6 plus 2 minus 1. So it will be proportional to P raised power 6 minus 1 and 1 minus P raised power 8 minus 1. So this is again form of beta distribution. Yes or no? So this is the posterior distribution will be, what is the posterior distribution? Beta with parameter 6 comma 8. Okay. Sometimes people make mistake. They wrote, they are writing p raised power 5, 1 minus p raised power 7, and answer is beta 5 comma 7. No. What is the PDF form? Alpha minus 1, x raised power alpha minus 1 into 1 minus x power beta minus 1. Then I will say beta, it will follow beta distribution with parameter alpha comma beta. So that's why option number C is correct. 6 comma 8. Is the clear? Question is clear to all of you?
Sir, could you please show me the question once again? The whole question,
Okay.
the question statement. Sir, then what is the use of this? Consider 10 independent throw and let x be the number of times 5
What is
appears on
this?
the die. Acha,
You are
okay.
throwing,
Okay.
correct?
Okay, okay.
You are
Yeah,
throwing
got
the
it.
die, and out of 10 times you are getting 5, right? And 4
Sir,
times
I
5.
thought, yeah, sir, I thought 5 occurs 5 times, so that's why I'm getting wrong. That is
No, no,
7.
no.
Okay. Got it, sir, got it. Yeah.
Now the see, I mean, that was the comprehension question. The second part is you have to find the posterior mean, by using the correct prior. So we got prior, and we got the correct posterior as beta 6 comma 8, right? And we know if x follows beta alpha comma beta. So this can be considered, you can consider m and w1, w2, anything. That's not a problem. So what is the expected value of x? Alpha divided by alpha plus beta. Also, do not worry about this PDF form of beta and expected value of beta distribution, gamma distribution, and all. These all things will be in the formula sheet, but it will be good if it's in your mind. I mean, it will save your time. I mean, there is nothing to, you to scroll up and scroll down to check the formula and all. So it will save your time if it's in your mind. If it's not, don't worry. You can cross check with the formula sheet. Okay. So anyway, so what will the posterior mean from here by using this information? Tell me. Posterior mean will be 6 divided by 6 plus 8.
6 by 14.
6 by 14. What is the value of 6 by 14? 0.43, which is this part. Yes or no? Clear? Yes? No? Okay. Okay. Is this clear? Posterior distribution part?
Yes, sir.
Okay. So there is one more question. Now, I would like to, I mean, I would request to try this question again. I mean, here prior is different, and likelihood also different. So you have to use this part. Okay, let's. I will give you some 2 to 3 minutes. I mean, okay. So just solve this and let me know whether you are getting option number D as correct or not.
Sir, what is this? The prior, actually, there is a the pointer is coming. Okay.
Okay, so option D is the correct. So you got right.
Can you give
What
one
about
more
others?
answer?
Okay, all right, no problem, no problem. So you should get the concept. That's the main idea.
Sir, PDF of gamma distribution is lambda alpha minus 1 e की power minus lambda beta ना?
Okay, let me write in general. Okay, so suppose I'm saying x follows, x follows gamma. If x follows gamma with parameter, it's alpha comma beta. So there is no need to worry about the denominator part. There is something in denominator part because that's constant. So that will come under this proportionality sign. Okay, so main thing is x raised power alpha minus 1 into e raised power minus beta x. Okay. So anyway, see, you have to use the concept that posterior is proportional to, right? So we are not using the equality sign. We are just ignoring the constant term. So that will come under the proportionality sign. Okay. Is this clear?
Yes, sir.
Okay. So you can use this information. Okay, should we proceed or?
Yes, sir.
Okay, great then. So did you, everyone is getting option D or not? You are facing any difficulty?
Sir, my beta value is getting coming wrong. Alpha is 40, but I am getting beta value as my 9.
Okay, no worries. Let's see. So what is the posterior part? So we know posterior is nothing but proportional to likelihood times prior. All right. So what is the likelihood? Likelihood is nothing but it's about see probability of observing your samples, right? So this likelihood we will get from Poisson distribution. What is the PMF for Poisson distribution? E raised power minus lambda, lambda raised power x divided by x factorial. Okay. So what we will can I write? E raised power minus
Okay,
lambda,
got
lambda raised power x1 divided by x1 factorial. Yes or no? Into e raised power minus lambda, lambda raised power x2 divided by x2 factorial. Let's do in general at least for now. Okay. Okay. Or else,
get it.
so how many times? 10 times, right? E raised power minus lambda, lambda raised power x10 and divide by 10 factorial. Yes or no? Because you can see data is about 10-week period, right? Into what is the prior? Prior is the gamma 5 comma 1. So what should be? It should be lambda raised power 5 minus 1 into e raised power minus beta x. So x is random variable. Here lambda is random. It will be minus beta is 1. Beta, sorry, e raised power minus lambda. Yes or no? Is this
Yes.
clear?
Yes, sir.
Now, see, all constant will come under this proportionality sign, right? So you can see whatever the x10 is there, right? So x1 factorial means 2 factorial, 5 factorial, 4 factorial up to this part, right? So this will be come under the proportionality sign. We have to worry about this variables. So you can see e raised power minus lambda into e raised power minus lambda. How many times this is? 10 times,
10 times.
right? And lambda raised power x1 into lambda raised power x2 up to lambda raised power x10. Okay, this is the likelihood. And prior is lambda raised power 5 minus 1 into e raised power minus lambda. So you can see this is proportional to e raised power minus 10 lambda, right? Minus lambda this one. So e raised power minus 11 lambda and lambda raised power summation of xi, I is equal to 1 to 10 plus 5 minus 1. Are you getting? All powers will be added. Is this clear? Yes, no?
Yes, sir.
Yes, sir.
So this posterior will be proportional to e raised power minus 11 lambda. Sorry, one second. It will be e raised power minus 11 lambda into lambda raised power. It will be 5 plus
35.
summation
So
xi
35.
minus. So now you can see the form of gamma distribution, right? If you see the gamma, if I'm saying x follows gamma alpha with parameter alpha comma beta, then PDF is proportional to x raised power alpha minus 1 into e raised power minus beta x. So you can see here lambda is our random variable, right? Instead of x, we have lambda. Okay. So this posterior is, okay, first of all, this will be e raised power minus 11 lambda and lambda raised power. If you add 5 plus all summation of xi. So xi is this, right? 5 to 7, 4,
It's coming
11,
out to be 35.
35. Okay.
Yes, sir.
So this is 35 minus 1. So what is the final form? We are getting posterior is proportional to lambda raised power 40 minus 1 e raised power minus 11 lambda. So by using this information, what is the posterior distribution? So posterior distribution is nothing but gamma with parameter 40 comma 11. Would you agree with me?
Yes, sir.
Right. So you can see. So option number D is correct. Okay. So sometimes people write 39 comma 11. They subtract 40 comma 1. No. So it's alpha. It should be in the form of x raised power alpha minus 1 into e raised power minus beta times. Is this clear? Did you get the idea? Yes. No.
Yes, sir.
Okay. Suppose the next question is, which is the useful to this part actually. We have to find the posterior mean. And if we know x follows gamma with parameter alpha comma beta, what is the expected value? Alpha by beta. So we got lambda as a gamma with parameters 40 comma 11. Then what will be the posterior mean here? 40 divided by 51. Yes or no?
Yes.
Sorry, 40 divided by, sorry, 11,
11, sir.
right? Sorry, I mean of beta was in my mind. Sorry. So 40 divided by 11 is nothing but 3.6. Okay, is this clear? Yes, no?
Yes.
Okay, so is this okay? Then I would like to, I mean, you should try this question. Okay. Again, gamma and all, but I want to give you the idea whether you are getting the same thing. Again, let me write the PDF of gamma. If x follows gamma with parameter alpha comma beta, then PDF is proportional to x raised power alpha minus 1 into e raised power minus beta times s. Use this information and find the posterior distribution of, I mean, whether you are getting D as a correct or not. Okay. So just take 2 or 3 minutes and then we will discuss.
So this is the last question for today. Hello.
Yes.
Sir, one thing. Please upload the PDF because I have to leave. I have some other session.
Yeah. Just after this session, we'll upload.
Sir, can you
Okay, so are you getting or you are still trying?
Done, sir.
Done? Okay. Should I do or should I wait for a few minutes if you are trying from on your own? Anyone? Any thought?
Sir, this question of second part, part 2.
I think posterior mean should be there, I think. Yeah, posterior mean only.
Okay, okay, okay.
Okay. Okay, should I start solving this problem, or you are still trying? Then we can wait.
Sir, start.
Okay, okay. Which class you have? I think yesterday I asked you
Sir,
people told me there
Python,
is no class at 8.
Python live session suddenly scheduled.
Okay, okay, okay. Then let me finish quickly. It will take 2 or 3 minutes. Okay. So if prior distribution is of lambda is gamma 5 comma 1, then f of lambda will be proportional to, tell me, lambda raised power 5 minus 1 e raised power minus lambda, right? Yes or no?
Yes.
And what will the posterior again? So posterior, I will solve it quickly. Don't worry. So posterior is proportional to likelihood times prior. So what will the likelihood? So 10 for 10 days you have collected sample, right? So I'm writing. So it will be e raised power minus 10 lambda directly, right? Okay, let me write a step, one more step. Otherwise, maybe you'll get confused. So it will be e raised power minus lambda. Lambda is power x1 divided by x1 factorial. Similarly, e raised power minus lambda. Lambda is power x10 divided by x10 factorial. And prior is lambda is power 5 minus 1 e raised power minus lambda. Correct? Now it will be proportional to e raised power minus 10 lambda and lambda is power summation of xi's, right? I is equal to 1 to 10. All the xi's will be added and into lambda is power 5 minus 1 e raised power minus lambda. So now from where we will get e raised power minus 10 lambda minus lambda is this minus 11 lambda and lambda raised power. What is the summation of each xi actually you can add? So
20.
7, 4, 11,
28, sir.
20,
8.
28. Okay, so it will be 28 plus 5 minus 1, right? So you can see this is proposal lambda raised power 33 minus 1 into e raised power minus 11 lambda. So again, this is form of PDF of gamma. So posterior distribution will be gamma 33 comma 11. And what will be the posterior mean? So posterior mean we know it's alpha by beta. So posterior mean is nothing but 33 divided by 11, which is 3 only. Okay, is this clear?
सर
So
प्रीवियस
we
पेज
have
एक बार दिखाइए सर. हेलो.
clear. Any doubt?
Clear.
Yes, sir. Okay, okay, sir.
Oh, okay. Okay, so we have done the week 9 and week 10. Okay, so I hope you have learned something from today's session.
Yes,
Yeah,
sir.
so someone was asking questions from PA. Is he there, or you want to try on your own and you can ask later? Or what's your thought? I forgot the name actually. Maybe
Sir,
so. Those,
actually,
Hmm.
sir, in the upcoming week, on Wednesday, you have scheduled one more session, 11, 12 revision. Will you take it or
Correct,
some
correct.
other instructor?
I'm not sure because
Sir,
so
try to
one
take
week.
it, sir.
So
Because
yeah,
question
yeah. So
solving with you is a great experience.
yeah, so if I will be available, then I will take, otherwise other instructor who, okay, so who is available, they will take. Okay, that's not a problem. Okay, so someone was asking, he has doubt, he had doubt in
Sir, one more thing, sir, mock test कब release करेंगे?
by tomorrow.
हाँ सर, डेडलाइन थोड़ा सा एक्सटेंड कर देना सर, वो मतलब
Okay, okay, no worries, will do, will do. Okay, maybe tomorrow or day after tomorrow, we will release the mock. You will get the announcement for the same. Okay, someone had doubt from PA. Is he there or
Not in the meeting, sir.
okay? So okay, if maybe you can ask to me or you can ping me on Discourse. You had doubt. Okay, then great. I hope you have learned something. Is there anybody anything else or no? Yes, no, nothing.
No, sir.
Okay,
Thanks.
okay, great. All right then. Thank you
Thank
all.
you, sir.
Bye.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you, sir.